Hello everyone. Myself Ashwini Singh. I am final year undergraduate at IIT Kanpur. Also, I'm a research fellow at MRC. Today I would like to present my research topic on 3D biogeochemical analysis and modeling for predicting the potential fishing zones in the Konkan coast. Firstly, why Konkan coast? Why we have chosen Konkan coast for our research? Konkan coast contributes around 41% of Maharashtra's total GSDP, and along with this, around 3 lakh 50,000 fisher folks are living across the Konkan coast region in the areas like Ratnagiri, Sindhudurg, and Raigad. Along with this, we have also seen a vast decline of around 42% in fisheries collection in this region, which led us to believe that a lot of climatic factors like ocean acidification, warming of water, and urban flooding are responsible for this. So, to understand it deeply, we are implementing our model and research on the Konkan coast. So, what we are doing? Our current challenge is to know how the fishes vary in the Konkan coast region. So why we need it? There are already some systems currently in work which do the same thing, but there are various limitations they currently have. So we will be catering that. Along with this, uh, it also helps the fisher folk community to know if they already know when the fishing will be high, where the fishing will be higher, in which time of the year the fisheries stock will be higher in a particular place, then the overall output they will be having by going into the area, the farmers will be have higher fishing collections, and this will overall increase their productivity. Along with this, it is also essential for the livelihood and policy making. Like if the government knows how the fishing trend will be changing, how with time and area in throughout the ocean regions, there will be a better policy making of when to ban the fishing in particular regions and when to restrict them. Along with this, this will also help us in stopping IUU fishing, as now we will have the numbers and the data like where the fishes stock will be higher. So now we can deploy our officers, the patrolling police forces in the marine places where these fishes stocks are higher. So that will be the reason for the IUU fishing. Along with this, it will also help us in predicting the climatic impact or climatic changes that is going to be happening in the oceans. It will depend on the fishes stock. So what we are currently doing and how it's different from our current solution. The current limitation of the current solution is they are currently using only satellite data and only taking very few parameters, two parameters into account, which makes this whole prediction a little bit limited. Like they just take only satellite data and they take a depth which can only capture the readings up to the depth of 1 to 2 meters. Instead, if we come to our solutions, we are taking multiple parameters, to be exact 5 parameters, and we are even considering the depth also of about 100 meter, which will give us a whole comprehensive analysis of the whole water level along with the depth of it also, which can also indicate the future blooms or the future activities that is going to be happening to cause of the depth factor. So how we are doing it? Our methodology involves around the depth and the multiple parameters, and we are combining all these multiple five parameters into a single parameter, and based on that parameter, we are identifying the potential fishing zones, and we are doing this for a depth of 100 meters, as I have talked earlier. So how we are doing it? The five parameter that we are going to be using is NPP, net primary production. It's the main food layer or food. It's the bottom of the food chain of the marine fishing life, which is most important for a fisheries. Second, O2, which supports the life of fisheries in these regions, and then is another gradient, which is responsible for the nutrients available in the region and how it will be changing in future. And then the fourth one is temperature, and we have combined all of this to get a single composite single composite suitability index, which formula is written here. We have given them different weightages based on their importance, giving NPB the highest weightage, and using this we are getting a single index, and we are getting this index for different parts of the region of Konkan coast, so that we will know it will be in a range of 0 to 1, and just looking by the single score we will be able to tell like how the fishing will be there in the particular region and how it will be changing with time. So for doing this thing, we have taken data from CMEMS Copernicus website, which gives us data using satellite data. Along with this, it also considers the in-ground sensors and gives an integrated form of data which has both of the both of two, the satellite data and the sensors data, which help us to identify and figure out things more clearly and do proper predictions. And then the same, we are using trapezoidal rule to cover the depth of 100 meter. So this depth also enable us to figure out like how which type of fisheries species will be available in which depth, as they also depend on temperature. So doing a depth analysis also enables us to know about the type of fisheries stock that will be getting in a particular region. Along with this was the final result that we have gotten, which is also verified and cross validated by research from Indian agriculture research institutes, which shows like that potential fishing zones will having a bloom in winter season of around 152% in time of around October to January, and also it will see a fall of minus 3.4% in seasons of June to September. So this can also be explained using various real environmental phenomena that is happening currently in oceans. So we got the prediction like from this current year data training, we got a prediction like that the currently fishing trend are going catches are going to exceed by 5%, and this will also going to improve the oxygen availability in water. So during our research, we also found out like there was a very sharp negative correlation between the temperature and the net primary production, which is also explained in how why there is a winter bloom of around 0.67 index, and there is a fall bloom which is very less compared to the winter. As in winter, the temperature is lower, which enables water to hold more oxygen, and there is more number of convective mixings, and more nutrients come to the surface and increase the overall nutrient available for the fishes. I'll be explaining it in the next slide also. Yeah, see, so this is what is happening in winter and what happening in fall, like in summers. So in winters, the temperature is normally cooler, so water holds more oxygen. Along with this, the top of the surface of the water becomes dense, heavier, so it starts moving below, and the lighter water from below, which is also rich in nutrients, cause the top surface layer nutrients is being eaten by the fishes, so they are declining. But the bottom layer, the depth layer, which have more nutrients, is still there. So they start mixing, the nutrient rich bottom layer start moving towards upside, and it replenishes the nutrients available in a region, which attracts more and more fishes in that regions. And this whole phenomena is called convecting mixing. The same thing can't happen in summers, because in summer the water become stable at it is lighter and it's on the top surface, and even the warm water holds less oxygen, so there is also less number of oxygen available for the fishes in summer, which indicates why we are getting the result of less number of fishes in summers and greater number of fishes collection in winters. Along with this, we are also considering the like I've already told you, like we are taking into account five factors, in which one of them is oxygen. What current scenario is like, they are current solution is using only chlorophyll readings and temperature readings, which doesn't account for oxygen paradox. Like sometimes what happen is, when there are nutrients on the top of the surface in oceans, and if fishes don't come to that location for some time, they start decomposing, and they are being decomposed by aerobic decomposition using microorganism, and during this decomposition, they use up all the oxygen in that region and make that region oxygen minimum zones. So if we see from the normal data, like yeah, that location has the nutrients and the temperature is okay, but in reality the oxygen is not there, so that is oxygen minimum zone, and we won't be finding any fishes in these regions. So this was the special case that we are covering, and that is not being currently covered in the standard solution. Yeah. Along with this, it also there's also a report which shows like these oxygen minimum zones are currently increasing, and they're pushing the habitat of fishes down to the water around by 30% every year. It will be in next 2 decades. So, with all these things, with the current modeling framework, we are using IPCC vulnerability model to assess all the future risks that is going to be in this field. Along with this, in this our solution, we are taking multiple parameters. That is why we are calling it 3D geochemical and geochemical analysis called geobiochemical analysis called. It takes into account geography, biology, and chemicals of the ocean regions, and taking all things into account, it's giving a common suitability index, which we are currently using to plot the whole Konkan region into a map. And with a single map, we'll be able to locate regions with higher productivity in fishes collections and with lower productivity. And similar, it will be help us for the stakeholders, which are the government policymakers and the fish farmers. So to conclude my final statement, we can use this modeling framework to do predictive analysis. We won't like be we are currently what is happening, we are currently on a reactive basis. We get the physics collection results, analysis reports, and then we make rules, we form rules, we do predictions. But using our current methodology, we will be able to get this data, get the future predictions beforehand, and we can make the amendments, make new policies, and make rules to ensure that everything goes right. Yeah, thank you.